referencing the new row and column it should be on. So that looks good. And then once you've clicked and dragged it across, you would just click and drag it down to fill in that formula. And that's all you got to do for that one formula. So enter formula here, and then just basically click and drag it across for filling in those green sections. We do not enter any formulas in here. As you can see, these are numbers that are populating. These are values that will populate when Solver runs. So you leave that part alone. The next formula you enter is in production cost, and that formula is equals unit production cost times parentheses early production plus B29. So if we scroll up here, we can see that the information of unit production cost of $2 times the early production cost, so it's telling us here, plus this amount. And we can't say later production, because if we did that, it would enter all of these values, and we don't want to do that. We just want to look at the values at this time period. So we say the production cost for that time period has all those values in there, and so that's that formula. And then again, you can click and drag this across, so you're going underneath where the green items line up, and then you have the formulas you need there. The next formula is the holding cost formula, and that is holding cost times the max of early production minus B13, comma 0. So what it's telling us is to apply a holding cost for the maximum amount of possible that could be held in inventory, so we can truly estimate the most cost we would have for us. So it's saying our holding cost is $1, and then we take the max amount of either the early production or this amount here that's in B13, the predicted production amount or predicted demand amount, or you would take 0. So if neither of these are, most of these are below that, you would take 0 as the amount. So if there's a negative number here, it would then just go to 0. So here it's telling us it's 10,000 minus 8,000, and then we take that 2,000 times $1, and that's how we have 2,000 here. So we drag this across to fill in that formula. And again, as you can see, it drags it to look at the correct one as you're looking at each various amounts, and you're looking at that specific time period. Okay. So then the next formula we enter is selling price. So we're trying to look at the sales revenue. So we say selling price times the minimum amount of B13 plus B18. And then you have that early production plus B29. So what it's saying here is it's going to take the minimum. You're either going to have this demand amount that it predicted of 8,000 plus 16,000, so that could be a potential predicted demand amount, or the actual early and late production that the solver predicts for you, and you're going to take the minimum amount of that, and you're going to times that times the selling price of $15, and that's where you're getting your sales revenue. So it's kind of giving a low end of sales revenue, because you don't want to necessarily overestimate it at first. You want to take the lowest possible amount to estimate. So you drag that across, and then here's where you'd want to make sure you drag that down 7 rows, and so you can see you have that there. So you're filling in the different amounts, and that basically triggers off of all these variables in here to cover those. So if I look down here, if I'm clicking in this cell reference and I click here so I can see what's highlighting, I see these values are highlighting because I'm in this column, and then I can see up here that I'm on row 5, so that's 1, 2, 3, 4. We're 4 rows down. I'm on the 5th one. I'm on 1, 2, 3, 4, and so I'm triggering the right one because I've lined it up correctly, and then I'm triggering that value there. Okay, and then the expected sales revenue is where you take the sum product of all of these varying amounts of what you're expecting, because this is where you're talking about the demand for all these different time periods of when you're looking at how you expect demand to be. You're taking that expected sales revenue, so you have sum product of B32 to B42, and then it's looking at the column over here, and you're using the absolute dollar signs or the dollar signs to show an absolute reference, because you don't want it moving over into these other columns that will have no information. So you need to say $I, $18 to $I, $24. So that number is stable. You can see here, these do not have dollar signs because we want the values to move as we adjust it. So you've entered that value here, and then you can drag that across. And then as we click in, like let's say this one, you can see these are still absolute dollar reference, but we're looking at this column now. And so you're going to multiply off of those. Okay, so there's where you're looking at the probability of that, and you're at the expected revenue. Now, the markdown revenue is the possibility that we have to sell at the markdown price. So you say markdown times the maximum amount of early production, and then this later production period here, minus the predicted demand. And so you have the B13 and the B18, and then you take 0. So you're taking the maximum amount of whatever could be left over, and you're timesing that times the markdown price to estimate the maximum amount of markdown price you would have to have. And so you can see here that we have a $ in this formula, and we also have a $ in this formula, because we want to reference those cells and keep them steady. So when you have the B29, you want to keep it on the 29th row here, so you don't want to vary. And then you also want to keep it on the B13. You want to keep that on that row because you don't want to vary from that row. You want it to go straight across. So when you have that value in there, you can then click and drag. You can either click down here and then click this across. Either way works, or you can click across and click down. So then we can see here that if we look here, we're again looking at just this row. We're staying in this row, and then we're also staying in this row. And we're looking at all those values. Then for the expected markdown revenue, it's kind of similar to what we did earlier. We're looking at B, we're summing this column, basically the sum product of this column, again with the $ on the I and the 18 and the I-24. And you can see over here we have these referenced again. So we're just now summing this up, and then we click and drag this across. So as of right now, we can see with the solve formula the way it is, it's showing we should have no markdown revenue, but that could change, you never know. Other formulas that we need are production cost. And so here we're summarizing the cost for production, where we say production cost here, and then we're taking them times these probabilities up here. And we don't have these absolute cell referenced because it's just going to be that one value. You don't need to worry about that. It's not dragging across anywhere. For holding cost, we have the sum product of the holding cost times the probability of those amounts. And these were their pretty steady demand amounts. Then the sales revenue, you're taking these expected sales revenue times the probability of those demands. Now, as you can see, these demand amounts equal the same as these demand amounts, but they could vary. So you could have more information that it gave you and they changed. So you want to make sure you reference the same ones in case or the correct ones in case the values had changed for the model that you used. And then this here is the markdown revenue. You can see you're taking the expected markdown revenue times, again, these probabilities up here to make sure you've done them correctly. And then you have this value down here, your total profit, where you have the sum of B57 to B58, which are your revenue amounts, and you're subtracting your cost amounts from that to get your total profit. The final step is to run Solver. So we go to Data, we click on Solver, and then from there you can see you have profit as your set objective. And if it's profit, we always want to maximize that, so you maximize. And then you go to changing your variable cells of earlier production and later production, because that will impact your profit amount. And then you have these constraints where you say that early production has to be less than or equal to early capacity, and then later production has to be less than or equal to later capacity, because we cannot exceed production based on capacity. Then you'd have this checked as usual, it's automatically already checked. And then the key here is to change this to evolutionary model. So it's evolutionary, and this is where we have a lot of problems with Solver. So some of you will have it where it takes quite a while to crunch, and it may come back. So let's go ahead and crunch this here. And if it comes back and says, oh, it's come to a certain spot where it stopped, as you can see, mine's crunching quite a lot, and it says, okay, we've come here, we've solved all the constraints. You may have a message that comes up and said, we've solved it as much as we can. Do you want to continue solving it? Just click, leave it alone, like cancel it and just leave it at that. Because if you do that, I'm telling you, it'll probably crunch and crunch and crunch and crunch and crunch and may have some issue. But this one went pretty quickly because it's already been solved. But if you do have any issues, The point of it is that it's supposed to tell you, here's what you should do for early production, and then here's what you should do at these varying amounts for later production. And then you would maximize to get the total profit of 194,518. This model I do find is a lot trickier with Apple. It has a lot of issues in crunching. I find this one to be very frustrating for running for the test, so I'm glad we're not having to have a test on this one, to be honest. Sometimes I've told students to go in here and enter amounts just to make sure their formulas all work. So you may want to enter, 5 here, and then you could have 5, 5, 5 across, etc. Just any value really, just to make sure your formulas are working, because you could see that they're filling in and they're calculating, and you're not getting any error issues when you're calculating the formula. So that's the supply chain model. It's a very encompassing model, and it can be very valuable working in supply chain, and hopefully that helps provide some information to you as you complete the model and submit it. Thank you.